So you could go straight across and then go over. That's path one, right? What else could you do? You could swim like that, right? What's the other thing you could do? You could go over and then walk less than that full amount, right? Is this very similar to what we just did, right? So let's label this here. Let's label this distance x that you walk on the ground, and then y as the distance you swim. So what's the time function going to be? You want to minimize time, right? So time, in this case, is going to be what? X divided by?
X over 2, y over 3.
Plus what? Y over what?
Plus y over 3.
Exactly. Do you see where that came from?
Yeah.
Why is y over 3? Because you walk at, sorry, you swim at, is it y over 3? Interesting. You can swim, oh no, you can swim at 2. It's got to switch those, Noah.
X over 3.
It's x over 3 and y over 2. I mean, it wouldn't be that insane to, maybe terrible terrain. You might have like really mountainous terrain. You could swim faster than you could walk on certain terrain. Is that correct?
Yeah.
We're good with this? So what would we need to find out now? We don't want to take the derivative yet because
we want to solve for one variable.
We want to solve for one variable. So to solve for one variable, we need to find an equation to solve for one variable. We need a new equation, right? What kind of triangle do you see there?
Right.
So you have this. What's the distance? Let's call that point B. What's the distance from B to C? 1. It's 1, right? So do you see the right triangle that Y is in? It's right there. So tell me what that equation is. Y squared is equal to 1 squared plus
1 squared.
Careful, not 1 squared.
I thought that was 1 mile.
It is 1 mile. That's the first one, right? 1 minus what?
Oh, x.
1 minus x squared. Is that correct?
Yeah.
Yeah. So what does y equal then? The square root of 1 plus.
1 minus x.
So what do you do with this now? You plug it in, and then you have t equals x over 3 plus 1 plus 1 minus x squared to the...
Wouldn't the fastest way to... Oh, wait, we don't know.
We don't, because here's the thing. The person swims slower than they walk, right?
Yeah.
But it is a shorter distance just to swim it. It's the same exact situation as before, where it's faster to get to the shore and walk, but the quicker you get to the shore, the longer the distance is. So it could be somewhere in between. Now, are you okay with what we just did there? Do you understand how we got to that equation? What would you do next? We're not going to do it. What would you do next? You take the, set it equal to
0.
solve for
Variable.
x in this case, solve for the variable, test it to see if it's a minimum in this case,
Yeah.
and then answer the question. But this right here is the big setup right here. Okay, get out of here.